Good. The camera's in the right place. Let's make sure the audio is on. Sweet. And actually, no. Yes. All right, and we're back for part 2 of measures of central tendency. Um, hold on a minute, I gotta edit this. Okay, yeah. But we're back for part 2 of measures of central tendency. So we went through that first example. Now you have a good idea of how to find mean, median, mode, mid-range, and then like we talked about, then you want to actually get a distribution of the data going so you can kind of judge which one of those is the best plays, the best representation of the middle of the data or the average of the data. That's what we're going for. That's the whole point of those measures. So let's do it again. I usually have the, the projector up here. But especially for this, kind of like we did last time, I realize I think I just need to write the data up there and then we kind of do the work from there. So the problem I'm looking at, this is section 3.1. Problem I'm looking at is number 3. So kind of pull up the PDF of the textbook from Alex for yourself. And let's look at that. And again, sorry, I don't know what's up with this room. I was teaching in it earlier and the front lights were fine. I turned them on, but 3 hours later when I came in, they're not turning on. So not sure what's going on with the front lights, but I think you guys can still see well, so all good. All right, so number 3. So this is again number 3, exercise 3 out of section 3.1. Jump there in the PDF. This is the last example we looked at was paid holiday days in different countries. Here is the length of school years, and this is not a huge sample. This is not a. We'll see later on in this course that really, honestly, you want your samples to be a lot bigger than this, but nonetheless, the lengths of school years in a sample of various countries in the world are shown. Find the mean, median, mid-range, and mode of the data. So this is, again, so they picked 6 random countries, looked at the lengths of their school years. Obviously, when they're talking about school years, they're talking about K through 12. So the 6 here are 251. So let me write this. So the lengths of the school years are 251, 243, and this is days. 226, 216. 226, 216. $196 and $180. I will say, notice that this data is given from greatest to least, so you already have your data basically lined up to be able to find the median. Otherwise, all right, so we kind of want to get to it. Now, like I said, this is a small data set. So this actually was from a US News and Report, sort of survey and then article that they did. So we'll talk as we go a couple reasons why we want, or I think I'm going to talk about a couple reasons why we want this sample to be larger. But yeah, so we want the sample to be larger than this, but nonetheless, this is a good sample. So they picked 6 random countries out of the 240 some odd or whatever there is in the world, and these were the number of school days that kids in K through 12 have to go to school. All right, so let's start with mean. So I'm actually going to give you guys a second to do each of these calculations. Again, since you've seen it, you kind of know how to do these. There is a couple of our calculations that I want to talk about, but we'll start with mean, and I'll have you guys go ahead and calculate this real quick. So on, I call it on your side, go ahead and pause. I'll pause on my side and calculate that mean really quick. Good. Let's see what you guys get. So you just had to add all these up. So 51, well, I won't write all this all out just because it'll take a while to write, and that's not the point here. But we're gonna add them all up, so. Add all up, and in this case, we're dividing by, it looks like there's 6 countries. So really quick, let me do this, 494. 6. 720. 36. 1312. So adding them all up be 1312 divided by 6. And let me do this really quick. I do want to mention too, as I'm calculating this, that, so again, I was reading through the section again, for means, in the section, it says their rule for means is you always round to one more decimal place in the data you started with. So like our data is whole numbers, right? So we would round to the first decimal place. So know that for the homework. But for me, I'm going to give you guys a different rule because that is not, in my opinion, not a good rule. You need to round to what makes sense for what do you call it, the situation or the context you're looking at. We also talk about, if we get to it, we'll look at a problem where just the type of data we're looking at, also the possible answers you can, measurements you can get, and the type of data we're looking at will help tell whether just how to do your rounding. So like in this case, we're looking for an average number of days that the kids are in school, right? So kind of like our last example, my answer shouldn't have a decimal in it. You can't be in school for a fraction of a day. I mean, you can, if you skip school or something like that, or, parents take you out early or something like that, but we're not really including that as sort of the possibility in our context. We're not trying to have anybody skip school. And we're not trying to account for emergencies that go on and all that kind of stuff. So the reality that we're thinking of is kids have to be in school all day. It wouldn't make any sense to have a decimal. So again, in a problem like this, you get this mean, you're gonna want to round it to the nearest whole number. And the nearest whole number looks like this is gonna be 219 days. So again, we picked 6 random countries, and so then this mean is trying to say the average number of days a child spends in school, in the world is about 219 days for, the average number, the average country, or not average country, but the average days in school for a kid in some country in this world, it's about 219 days. Let's talk about median, or let's try to figure out median. So we did median on the last problem, and you guys did it easy enough. You listed it from least to greatest and you found the middle. Notice here we have it listed from least to greatest. So let's find the middle. So I'm gonna knock off the largest and the smallest, and then the largest and the smallest left over. Notice you run into a problem finding the median for this because you start knocking off largest, smallest, largest, smallest. The problem is because there's an even number of data points here, neither of these are in the middle. You would knock those off too, and then you're left with physically no number there. So that kind of doesn't make any sense. Like last time we had, I think, 11 bits of data. So naturally you had 5 bits of data on the left side, 5 on the right side. There was 1 in the middle. But because we have 6 here, we have 3 on the left side, 3 on the right side, and no piece of data in the middle. So then what do I do for the median on something like this? What we do for the median is, instead of then looking for one value to be in the middle, the idea is I'm gonna, again, knock off lowest and highest, lowest and highest. When I get to the middle, there's two of them in the middle. What I'm gonna do is I'm gonna find the midpoint of these two. You're gonna find exactly halfway between these two. So remember, when we do when I was talking about mid-range, I was telling you that, mid-range is just the statistics word for midpoint, right? And midpoint, whether you're doing that in algebra or whether you're doing it as mid-range here, or whether you're doing it in some other class with some other word for it, midpoint is always done the same way. You add up two numbers you want to find the middle of, and you divide by two. That's how you find the middle. So add the two, divide by two. So we're gonna do the same thing here. We're gonna do 226 plus 216, and we're gonna divide that by two. And do that really quick. We don't have to pause or anything, but do that really quick. What would that give you? Good. Adding these two together, it looks like that's 442 on top, and you divide that by two, so you get 221. So the median of this data is 221 days. So literally what I'm saying is 221. It's quite literally in the middle of these two numbers. It's 5 below 226, it's 5 above 216. So if we use the median as our average, as our middle, then we would say that the average country gives 221 days, or has their children in school for 221 days. All right, good. What about mode? So median was the middle, mode was which one happens the most. And what would y'all say here? Because notice, so again, with the mode, we sort of have, you might be, not just conceptually, but practically, you might be running into an issue. For the mode, we're looking for which number happens the most. But notice that I don't have any repeats here. So every number, there is no number that happens the most. Every number happens the same amount of times, right? So when that happens, there is no mode. Just because I ask for it doesn't mean it's necessarily there. So mode is looking for which number happens the most, which means I at least need one number to happen more times than the others, and I don't have that. So there is no mode for this data. But then we can easily calculate the mid-range. So again, the mid-range is the midpoint between the high and the low. I kind of just reminded you guys again how to calculate midpoint. So go ahead and take a second and calculate the mid-range. Pause on your side, I'll pause on my side. All right, easy enough. So my lowest is 180. Highest is 251. Add those up and divide by two. Notice again with this, so with this, actually when you divide this by two, you are gonna get a decimal. So again, for your homework, it's gonna say to keep the decimal. I'm gonna say to round to the nearest whole day because that's kind of what makes sense for this. But 180 plus 250. One is 431. Divide that by two. You get 115.5. So this is approximately 216 days, or the midpoint there is 216 days. So no mode, mid-range is 216, median is 221, median is 219, etc. All right. So now we have to figure out, and that's also what these questions ask, they then ask you which of these averages is gonna be the most appropriate one. And by that they mean basically fits what we see in a distribution of this data as sort of the average or the middle. So we got three different answers. Notice kind of like our last example, and this, not just like our last example, so I'm gonna say this happens very often, that you'll have usually two answers, maybe sometimes three of them that are really near each other, then another that's a little farther off. So again, notice our mid-range is kind of farther off. It is not likely gonna be our answer. You know, it's not likely gonna be the most appropriate um, measure of central tendency. It's not gonna be the one we choose to say is the average. And we don't have any modes, so even without seeing a picture of the distribution of this data, we've already narrowed it down to, you know, median. We gotta kind of look at which one's more appropriate. So that means we need a distribution of this data. And so, like I was saying on the last problem, that means you need to, before you sort of go do something about drawing a picture, getting a graph going, you need to decide which graph is kind of most appropriate for what we're looking at. So a bit like last time, we're gonna see pie graph is not a good play. Also notice that again, the dot plot is not a good play here, because we don't kind of have just one of everything. Second. So it's down to, like last time, it's down to doing a histogram versus a stem and leaf plot. I want you to notice on this one that even on this, or for this one, a stem and leaf plot even is going to be problematic, because so let's kind of test this out. To do a stem and leaf plot or something like this, I would kind of start, I guess, in my 180s. So I kind of start with 18. So that's 180, 190, 200, 210, 210, 220, 230, etc. All the way up to, it looks like we need at least up to 250. So if setting up a stem for my stem and leaf plot would be like this. But then if you start writing these numbers out, everything is going to be sparse. So you're going to have 0, you're going to have a 196, and you're going to skip the 200s. You have a 216, the 226, no 230s, you have a 243, and you have a 251. So let's say you look at this and you decide, oh, I want to go with the stem and leaf plot for the distribution. Well, this is what you get. Is there much shape to this distribution? No, there's really not much shape at all. This is maybe a uniform distribution, but we can't even really test that, because again, to really have a shape to the distribution, we need bars, or we need dots, or we need, you know, my leaves here to have to basically to be stacks of data. I need some of these need to be larger than the others. They need to be stacks of data so that I have some shape to this. And I don't, even with the stem and leaf plot on this one. So this one then, what you're kind of left with, and what this is a good, you know, what's a good play on this as far as getting a graph of the distribution, is a histogram. Because, you know, again, what I'm seeing here is my data is pretty far spread out. But what I could do with this data, so with a histogram, remember that you get to choose your classes. You get to choose basically how many classes you have, and therefore kind of how wide those classes are. So we could choose our classes in such a way between 180 and 251 that we need to have at least one of these classes, or a couple of these classes, to have more than one thing in it. And we could choose our classes in such a way that we're going to get that. So stem and leaf plot, because it's, you know, in stem and leaf plot, your classes basically are auto 10s, right? 180, 190, 200s. But we don't have to choose 10s when we're doing a histogram. Our classes could be wider than that. So the histogram is kind of the best play on this. So let's get a histogram going. So we're gonna get a histogram going on this. Again, you wanna look at your lowest and your highest. Lowest is 180, highest is 251, so you got a spread of about 71. And we wanna try to construct our class, or we wanna decide how wide our classes are gonna be. Um, so I think normally what we were doing with the histogram is we would say, oh, well, let's split this into somewhere between, you want to split it into somewhere between 6 and 10 classes. So if you split 71 into 7 classes, you're basically ending up with about 10 each. You know, your class width is going to be 10. And our class width on the stem and leaf plots was also 10. So if you do that, unfortunately, you're not gonna like your diagram, your bar graph is not gonna really look any different than the stem and leaf plot. So this is a unique example as far as creating a histogram, because usually that's what we do is we try to make sure we have 7 groups, roughly 6, 7, maybe 8 groups. But here we need our classes to be much larger, which means we need our number of classes to be much lower. So again, our range, by the way, when you do lowest minus highest, that's called the range. I think we did say that in the previous lecture, but just I felt like I only said it once and didn't emphasize it. So our range is 71. And so this time for this histogram, instead of thinking about how many classes I want to start to just think about how wide do these classes need to be so I at least get some of these to like concentrate, to gather up into one class. Um, um, well, but what I'm seeing here is, let's see, 15. I think again, there's no right answer here. What I'm thinking is, so we could one solution is just bump it up to 20, right? So just make it so that essentially, again, thinking back to like sort of the stem and leaf plot and the way we split it into tens, that 2 of these just become one class, right? And then so if 2 of these groups become one class, you see we get some of them to kind of bunch up. But if we do that, the only problem there is, let's see what we end up with. 1, 2, 3. We do end up with 4 classes. It's weird. Up with 4 classes. So we could do that. I think I'm going to split it up into 15s. So I have no great mathematical reason for that other than it gives us 5 classes. 4 classes just seems like you're making things so broad that you're like kind of, it's almost like zooming out. You're like scrubbing out some detail. So I'll kind of hit the middle and do maybe 5 classes. So let's start there. So I'm gonna need a table with my classes, frequency. By the way, so I was mentioning earlier that you really want your samples to be bigger than this. This is part of the reason why. So if my sample is only 6 things, then you can kind of I mean, you can kind of see visually and maybe imagine that really no matter how I split this, I'm probably just gonna get one of everything, right, in every class. Like that it's, like even thinking about we have 6 bits of data. So if I even make just 6 classes, I am more than likely just gonna get 1 bit of data in every class. And that would tell me it's a uniform distribution when it may not necessarily be a uniform distribution. So basically, just picking 6 for a sample is just way too low resolution. It's kind of like, again, zooming out on some picture and losing some detail, or you can think about it like, like when your game freezes or something like that, and you get those big blotches. We call it a so when it freezes or when there's some sort of glitch, some sort of, programming error glitch, and you get those big splotches, those big squares. It's like they they cover up everything so much that you can't see some detail about the shape. Like there could be more of a shape under there, but we've just got 6 bits of data. So you've just got a big gray block on your screen and you can't really see what's behind it, right? So that's why, and we'll actually talk in more detail, and there's actually a theory in statistics that kind of tells you um, basically a range of data that's good to pick for different, different populations that you're looking at. So we'll get to some more details. There's actually a theory that gives you a lot more details about, okay, so definitely you don't want to pick this little, but what should the size of my samples be to get a good measure of stuff like an average, a measure of central tendency? So that is one of the reasons we're having trouble finding basically a diagram that's going to give us any type of distribution or good, yeah, just a good look at the distribution of this data is because we only picked 6. But anyways, so I said I was going to do my classes by 15. So this first one then is going to be 180 to 195. The second one will be 196 to, and then we need to add 15 to that. So that's going to end up being 211. Third one will then be 212, 227. Fourth one will be 228. 243. I actually still don't think this is going to improve anything. Interesting. Then 244, 259. So if I choose my class width to be 15, this is kind of what I get. I don't know. So if I then do my frequency, and we'll just do it, well, I mean, you can just do it with me as I'm doing it on the board. This is easy enough. There's just 6 of these. So there is 1 between 180 and 95. There's a 1 between 196 and 211. There's 2 between 212 and 227. There is 1 here, and then there's 1 here. Let me we end up with something like this. And you could graph a bar graph from this. I think actually we don't even need the bar graph. You can kind of see the distribution from here. So what would you say the distribution of this looks like? Good. It's roughly a bell shape. It's kind of high in the middle, tails down towards the end. So my middle of my data, I'm expecting should be somewhere in this range. And notice that both numbers that we have here, the mean and the median, both fit that. So which one of these is the best or is a good approximate of the middle of the data? either one of them. The mean or the median would be, either one of them would be good here. Um, You kind of have a choice, looking at 219 and 221, whichever kind of visually and mentally makes a little more sense to you. I would probably say 221 because I do kind of, I don't know, I have two. So if I look at the spacing of these numbers, 180 plus 16 is 196, and then plus that's actually 20 gets to 216. Notice, I basically noticed that the numbers on the top end are a lot closer to each other. It's 10 between those. There's 17 between those. There's 8 between those. So it's like my data seems to be pretty sparse up to here, and then suddenly it kind of tightens up. And so because of that, I would expect, to me, it makes sense that um, the average should be a little higher in this range between the two options that I have. So I would probably call it 221, but officially, again, statisticians answer either of those is a good read on the average number of days. And notice that they're not too far off either from each other. So overall, the average country in the world roughly has their students in school, K through 12 school, about 219, 221 days a year. By the way, I didn't even look this up before I started this video, but we could do a really quick search on the US, right? So you can search average days in school. Gotta find a source from Google search you do that's actually gonna be legitimate, but let me look this up really quick. So average school days. You know, the thing with the US is interesting is every state kind of runs this differently, right? So um not that this is completely true for all the countries, but for most of the countries definitely have like in some sense they have different parts to the countries, but they don't have states, right? So the different parts of the country are more like counties, basically, what we think of as counties. Um, and so in other countries, and especially a lot of other countries, you know, some countries are huge, like us, and you know, physically, like land wise and people wise. Us, China, India, Russia, but most of the countries are pretty small or relatively small. So again, most of the countries, the way they do it is there's no like states with like separate ways that the states do, you know, the funding for the schools and the school calendars, and you know, just it's just there's just one schedule for the year. There's one way that school funding is done because again, there's no states in most other countries. um, Kind of a unique country in that we try to we try to disaggregate power. We try to have the federal, so we're sort of this balance between federal and state control of stuff. But average school days in a year, US. Trust that answer. That's the textbook answer. I'm looking at a website. So what I'm seeing over several websites, and one in particular that does statistical or publishes statistical data on, you know, the schools in every state or in the US, is it's saying the average is about 179 days, and most of the other websites I was seeing as actually 180. So this 180 is likely the US. So the US, our kids are in schools 180 days. Um, Now this is just a sample of 6. So again, by farther on in the class, one of the reasons we're gonna look at sample size and getting a good sample size for a population is, so again, whoever did this picked 6 countries out of 200 and, like I said, 40 some odd or whatever in the world. So if you think about it, if you pick 6 out of 240, you don't have to give me a number, but just give me sort of an intuition. What's the probability that, let's say, your six sort of hits the middle of the the middle of the results for all 244 countries? Yeah, it's actually not a great probability. It's kind of easy if you're just picking six to pick six low ones or maybe six high ones, right? Or a mix of even like low and high. Now it's probably just as likely to pick the middle, but what we're saying is if you're just picking six, you have a high chance of not picking the middle, maybe picking the sides of your distribution, some low countries or high countries as far as days in school per year. Um, so again, what we're going to look at in later in class is how high do I got to pick out of a sample, population of 244 so that I have a good read on maybe the center of the data, which is what we're looking for here. We're looking for an average. Um, so, um, so what I guess what I'm trying to say is I don't know how well this represents all 244 countries. Usually we want our sample size to be at least 20 or higher. But let's say that this does. Let's say this does represent, the 244 countries pretty well. We have some countries with low number of days, relatively low, some numbers with high number of days, and we sort of have this group sort of in the middle there. Then that if this does represent the 244 countries well, then that's you could start making some analysis, some conclusions that again our average is about 180. So US is actually on the low end of the countries of the world as far as number of days spent in school. Um, and I think that's probably pretty accurate, actually. Um, a lot of the schools, I had friends in college that were from South Korea, from Japan, from India, and a lot of other countries they do their kids spend more time in school than we do in the US. Um, Part of it too, not that Korea is a well-developed country, India is a well-developed country, but I'm just saying you find it often too in developing countries, they either have their kids basically don't spend any time in school, right? Because they're not focused on education. But the developing countries where they are focused on education, because that's kind of your way forward. I grew up poor, and that was one of the things that my parents always emphasized to us and taught us, which is true, was definitely true, especially for the US, is if you've got no money and you got no way forward, education is your way to change your situation and kind of move forward. And that's been proven true in the US. It's been proven true in a ton of countries all over the world. That's why there's been a huge push for education. It's not just to incarcerate people in a building or kids in a building or just keep people babysat. You can actually look up the statistics, the progress that people have made, the amount of money they're making per year, the not living in poverty, living in more middle class. It's not just in the US. It happens in almost every country where they make education a priority. Anyways, so like I said, there's some developing countries where it's not made a priority and the number of days will reflect that. But in a lot of other developing countries where it is about hustle and it is about work and they are trying to move forward, the number of days they spend in school is a lot more than us. They basically put a lot more work in. Um, and maybe as a country, we're in a different place. We put in a lot of work for 150 years, and maybe we're entitled to put in a little less work now because we've built a foundation. You could argue, maybe yay, maybe not. But I will say again, from people I know and also just stuff that I read and look up, we basically are being out hustled by a lot of other countries. Their kids put in a lot more work into school. Honestly, they're the people working jobs put in a lot more. I mean, I'm saying people here put in a lot of work, but they put in a lot of work. So they're possibly being out hustled by the kids in a lot of other countries because they're really trying to move forward. They're really trying to get forward. So it's something to think about. We are kind of so again. I I do want to preface what I'm about to say with I do need to look at all the data, but I'm pretty sure we are kind of on the low end. We are very much on the low end as far as number of days we spend in school. So, um, anyways, um, ooh, All right, so that's another good example. There's kind of two more things we need to look at in this section, but I'll just make that part of part 3 here. So this was part 2. Just basically, this one of the distinctions I really want to make here is, your median when you have an even number of items, and the whole idea of having no mode. So hopefully that makes a lot of sense to you guys. I'll see you guys for part 3.